To program a part, you go to Part and the New Part Wizard. New Part Wizard is to create a blank part or to create a copy of an existing part. Blank part is for new tooling, new tube on a new day. Create a copy of an existing part is for making more than one piece out of an existing type of material. Quite often done, quite a bit less typing to do. For the purposes of today, we're going to create a blank part. You can talk in inches or millimeters. We're going to talk inches today. We're going to change this to 0.375 because that's really what we have for an OD of your workpiece. Then we have a wall of 0.065. We have a center line radius of 2. And you can have different material here. You can enter in whatever you want here according to the nature of your material. In the New Part Wizard, you can always press the next button and the back button as you work your way through this. We're going to press next. We have to identify how many bends we have in our workpiece, which today it's 3. We're going to enter that. Also today we're going to talk about YBC, which is the way to edit and create parts not from a CAD drawing. XYZ is for use with CAD drawings. They give you information that way. We're going to go YBC. And next, we're going to make a part number, which is going to be 1, 2, 3, 4, 5. We're going to get a description of 3 bend. And we're going to press next. This gives us our YBC table. Center line radius is already filled in. So our first Y is our first straight is 2.5 inches. The next, we're going to enter that. The next straight is 4 inches long. The next straight is 5 inches long. You can use auto calculate last Y. That's a setting for part defaults. We're not going to use that today. And we're going to have the last Y of 12 inches. Next we're going to talk about B-axis. The first B-axis would be used to smear lube on the inside of a tube or orient a seam. We're not going to have anything there. We're going to have a 90-degree B-axis on this tube here, and a negative 180-degree B-axis between bend 2 and bend 3. Degree of bends, the first bend is a 45, the next bend is a 90, and the last bend is 130 degrees. Centerline radius maintains throughout. We're going to calculate tube length here, and it says that the calculated tube length is 32.75 inches. Would you like to apply that? We're going to say yes. So it'll fill in this box. Click if next. Here's your speeds. Default speeds are a good place to start. C return speed is your bend arm return speed. If you set it to 0, it'll return at the same speed as it goes out. If you set this to a low number, it'll return slow. A lot of people like to do that for safety considerations. When that bend arm is coming back, people get worried about it from a safety perspective. Carriage boost speed is how hard the carriage is going to push during an auto cycle during the moment of bend. It's a percentage of speed based on your arc length of your tube. 98 is default. That allows for 2% elongation of the tube, which you'll have that on mild steel. Different materials have different amounts of elongation. We're going to press next here. Programmable pressures are your pressure die pressure, which is the pressure die moving in and out pressure. PDA pressure is the cylinder for the pressure die assist in line with the tube. This pressure is used to eliminate wall thinning from the outside of the tube. Pressure die pressure is how hard the tube wraps around the die. These are also profilable down here. You can put more pressure at the beginning and back that off during a bend. Say you have a 90-degree bend, you can put a lot of pressure on it for the first 10 degrees, and then from 11 to 90 you can back it off. Very useful for thin wall tube bending and for different alloys of tube that are stubborn and don't like to bend. Here we have our tooling information. In this case, we're going to call our clamp die 1 inch long. We're going to call our pressure die 3 inches long. We're going to call our front interference zone 2 inches. Everything you click, you automatically get a picture here of what's going on. So our clamp length, that's this die right here, we're saying is 1 inch long for 3/8 tube. The rule of thumb is that normally is 2 times the diameter. So in the world of 3/8, it has to be at least 3/4 of an inch long or longer. The more the merrier. Pressure die length is your arc length plus 2 diameters. If you're going to have a 4-inch arc length, you're going to need 4 3/4 of pressure die length. In this case, we have a 3-inch setting here, so that means that our arc length is not to exceed 2 1/4 inches. 3 minus the 3/4, which is 2 diameters. Front interference zone is 2 inches. That's as far forward as we want the carriage to come ever, even with the pressure die open. Collet offset, if you have collet jaws that bolt in the face of your master collet, you need to put an offset in here because they stick out. And you have to allow clearance for that behind the pressure die and the wiper die. In this case, it's 0 because our collet fingers are entirely behind the master. Collet depth is the amount of tube in the collet during the bending process. C-max angle is, according to your tooling, the maximum allowable bend arm position. Some tooling only allows for bends up to 100 degrees and has various limitations based on the size and the material of your bend die, the material shape. Next we have load. Load position, you can always calculate the optimum load position right here in the bottom left-hand corner. BendPro thinks that the optimum load position for this part is 29.25. I don't necessarily agree. I like to have the carriage further forward than that, but we're gonna say okay to that for now. Everything else default is okay. If you have different preferences, you can look through these settings and change things according to how you want to put the tube into the collet. Next, we have unload. Unload default is, if you leave everything default, then where it ends up at the end of the last bend is where it will stay. You can unload, you can shove the tube off the front of the machine if you have an operator or a robot that's gonna catch it. There's different things you can do here for this. Next, we have enables. We're going to turn the mandrel on. You can turn on and off different things. If you have foot switches, this is where you turn on and off your foot switches. Some factories do not allow foot switches for safety. There's different rules about that. Disable B during bending is used for square tube and different profiles. We're going to, from here, save the part and close. That gives us a picture of it up here, which looks pretty good. I always go right to the part editor and go to bend and go to display tube to get a life-size picture of what this baby is all about. Looks right to me. You can blow it up a little bit. You can look at down here this bend, this true view, the first bend and the first straight. If you decide you want this longer or shorter, you can do that. But that is your first bend. That's good. That means that the long straight is definitely going to be in the collet. Bend 2, the green is the straight, the red is the bend. Looks good. Bend 3. It's going to assume everything else there is the last wire. We're going to move this around. And that tube does look like our workpiece. We can also animate the tube. And that is how the tube is going to bend. You can pan, look at this like that. And yes, that does look like our workpiece. Also, we noticed when we animate the tube that it's going quite fast. I would think that we would want to slow that down for our first bend, which we're going to close this and go to speeds. And you can set all speeds. So set this to 20. enter. This 20, set all speeds to 20, enter. And everything's at 20, that's gonna be much slower. Save part, display tube, and animate, that's much slower. Okay, so we have something that we can work with on this first part. We'd like to bend one. Of course, there's going to be spring back and other considerations, but we have something we can work with. Thank you for watching.